Fine. So, already we have discussed in the last class, that is about the design concepts. In a simpler manner, what we can call about the design concept is, it will be like a founder for making of this design engineering. This will be help as a software design as a prerequisite, and we had to give some answers like what criteria you are going to applying for dividing that problem or component into multiple components, and what sort of the functions or data structures you are going to using, and what is the uniform criteria for defining of this technical quality, because the output of the design is quality. In that aspect, we have seen the different design concepts over here. We have seen the different concepts over here, right? So among that, we have completed in the last about abstraction, architecture, patterns, separation of concerns. Let me look into this class the rest of the other design concepts from modularity to the design classes. I'll just jump into modularity. Here, the modularity comes. So the name itself talks about modularity is dividing, that is divides total software into number of submodules, number of pieces or number of separations is called as module. Now modules are integrated to satisfy the problem requirements. So how many number of modules is depends on the problem complexity, you can divide that much. For example, if you look into if you look into this, if you take a problem, two problems, P1, P2 as a two problems. For this problems, there is a complexity like CP1, complexity 1 for problem 1, CP2, complexity for the problem 2. To do or to put some efforts for this one, it will be calculated like P1 equal to CP1 and P2 equal to CP2. If it is automatically the complexity of the first problem is more than complexity of second problem, automatically the efforts also more. To make reduce of this, what we can do is we can divide this total problems, that is two problems, into many number of subdivisions, many number of separations, so that you can use normally, you can use normally over here, you can use normally up to how much the comfortness or flexible to solve that problem, that that much you can go ahead. So that dividing and integrating that problem solutions is called as divide and conquer strategy. This will be learn you in OS concepts operating system course. Divide and conquer. So dividing that problem and conquer in the sense integrating all the solutions together. So this is the best solution where we can broken into submodules and integrate again each module, each submodule solution, right? If you see a graphical representation, as I said you, the number of modules in the x-axis, it is going to be more, the cost and effort. See the cost and effort over here, the cost of this. So this curve talks about the cost and cost per module. Means the number of modules are going to be more, it will reduce the cost over here. If the number of modules is more, that is less, the cost is more. If the modules are more, the number of modules is going to be more over here, the cost is going to be reducing. And cost to integrate, now coming to this one, as it is to develop that module, the cost is very less if the number of modules are more. If the number of modules are more, if you see this cost to integrate, for integrating means for conquer, there is divide and conquer, the cost is more when the number of modules are more when you are going to be integrating. But for developing of each module, if the number of modules are more, the cost is less. If the number of modules are more, the cost to integrate is more. So the total cost here, if you observe here, the total region of minimum cost is required is, if you consider as M for this region where it will be crossing over there, for this region, the cost will be calculated. So that capital M shows you the total cost which required for developing and for integrating over there. Okay, so as the number of modules are more, the cost is less to develop it, but to integrate, the cost is more. Okay, Coming to the next design concept, that is information hiding. Information hiding, the name itself, hiding in the sense without it not be visible to, it will be invisible to the other parties. So invisible to other modules who don't need such information. So which modules require which type of information, that only has to visible for that one. For example, if you consider a phone pay, there we have different modules, like mobile recharge is one module, uh, transferring the amount is another module, making IRCT is another module, electricity paying bill is another module, credit card bills paying another module, or insurance paying or shopping another is another module. These are the different modules in the same application, right? So IRCTC is doesn't require the details of electricity module. Electricity module doesn't require the details of mobile recharge. Mobile recharge doesn't require the details of the transactions, which is required for making a phone pay over there. Such type of whoever the module required, that necessary information has to provide. That providing things is called as information hiding. So achieving by defining the set of independent modules that communicate with another, only information which is necessary to achieve that software functionality, they can be accessed over there. And if you provide this, you can have a greatest benefit when modifications are required during testing and later. Because if you are hide that type of things, it is very much beneficiable. When any changes is done for any module, it is not always required to inform to the other modules as well. For example, if in mobile recharge module in PhonePe, if any changes is done for that, it doesn't required to inform to other modules, because whoever the modules are directly interconnected to that, that can be informed over there, so that it can be more benefit whenever any modifications has done over there. Okay. If you see in detail about this, we'll go for the next concept, that is functional independence. Whatever the concept we have discussed, like we have discussed about the modularity, abstraction, information hiding, all these are the direct outgrowths of this functionality. So functionality is the directly, it is functional independence is directly the growth outgrowth of all these three design concepts. How means, here, it is going to be achieving developing a module with single-minded function and version to access, that is interaction with other modules. Meaning here is, if you divide the total problem or software problem into a number of modules, and M1, M2, M3 like this, all the modules M1 to Mn, all are will be independent to each other. Because when you are dividing that problem, for the same problem, you're not dividing for two times same type of functionality. Dividing a problem is what? Dividing as a modules. Dividing a module is means what? The functionality has to be vary. If the functionality of module 1 is same as the functionality of module 2, it is not required to divide as two modules. You can divide as only one module, right? Because both the functionality of the modules are same. That's why the modules, how many modules you are going to dividing, that M1 to Mn, all are to independent to each other. So that independence can be done with the help of modularity, abstraction, whichever the details is required, high level details, and information hiding. In detail about this concept, functional independence, if you see this, it is easier to develop and have simple interfaces because it is independent to each other. Easier to maintain because secondary effects caused by design or code modification are limited. Error propagation is reduced and reusability models are possible over here because it is independent. All the models are independent. Because of that, side effects, any change of in one model should not be needed to reflect it in other models. That is very less side effects will be there, right? If you go in detail about this functional independence, this independence can be accessed by two quantitative criteria. One is cohesion and another is coupling. This is a GATE question, GATE or any other competitive examination. Cohesion and coupling. Cohesion talks about a very less interaction between the modules is called as cohesion. If it is a more interaction between the modules, is called as coupling. So functional independence is required more interaction or less interaction between the modules. Obviously, it is less interaction. So who is providing less interaction? Cohesion. Who is providing more interaction? Coupling. So as I stated that at the last point of this is coupling should be low. Means more interaction should be low. Cohesion should be high for good design. What is the cohesion? single task requirement, that is requiring little interaction, only less interaction within other components. Other components means what? Other modules. So here what is saying coupling? Measure of interconnection among module. Interconnection is more interconnection is there. That is in the coupling. So that's why, as stated, coupling should be low and cohesion should be high. What is the meaning of that? Interaction between the modules is very less, low, and interaction between wherever it is. So interaction between the modules is whichever it is low, that should be always high. So which one is the less interaction between the modules is cohesion. That's why cohesion should be high, whereas coupling is low. Okay. Coming to the next concept, that is refinement and refactoring. Refinement, refining is what? Again, whatever the work we have done it, we can do some sort of corrections to make it in a systematic structured way. So process of elaboration from high level abstraction to the low level abstraction. Refinement means we are coming back again, we are seeing from top to bottom, and any refinement, any changes is there. Now we can say refinement can be done in two levels. One is high level abstraction, another is lower level abstraction. High level abstraction, already we discussed that it gives only the high level funda details, right? That is statement of function. So refinement causes the designer to elaborate, providing more and more details at successive levels of abstraction, because we are making from higher level abstraction to the lower level abstraction. What is higher level? The abstraction gives only the main words, the main keywords we are defining. What about the lowest level means, or lower level abstraction? We are giving in detail about that one, in detail information. So that's why refinement causes the designer to elaborate, providing more and more details at successive level of abstraction. And here, abstraction and refinement both are complementary concept. Complementary means what? Here, abstraction will use what details? High level details, whereas refinement will use low level details. That's why it is called as complementary, opposite to each other, right? So abstraction and refinement is complementary concepts to each other, right? Coming to the refactoring. Refactor. Refactoring is nothing but it is a organization technique. That's simply the design of a component without changing its function or behavior. Without changing its function or behavior, doing the thing is called as refactoring. This is also be interview question. Refactoring means without disturbing the actual behavior, actual functionality of a particular module. If you are performing some technique, if you are performing something, is called as refactoring. So design of a component without changing its functionality or behavior is called as refactoring. So examines for redundancy, how it will be do this refactoring is with the help of, first of all, it checks the redundancy. Redundancy means what? Any duplicates, any sort of duplicates of same repeated steps or there, or unused variables or unused sort of things is there, unused design elements is there inside, or maybe inefficient or unnecessary algorithms are going to using in the modules. Such type of examination like redundancy, any unused design elements or inefficient or unnecessary functionalities or algorithms are there, by examining this one they will be go for refactoring. Okay. So next concept talks about aspects. This is deals with the concern. Already we have talked about the separation of concerns, hope you remember. Now, aspect is nothing but whatever the module you have divided, like we are making separation of concerns, right? Dividing into each concern as a line separated with that. Each one that is providing the feature, providing that each line, each box is comes under concerns. Now, each concern will talks about the aspects. Aspect means what? A feature, a functionality, right? So, as requirement analysis occurs as a set of concerns is there, is uncovered. These concerns includes requirements, use cases, features, the data structures, quality of service, issues any there, QoS issues are there. QoS stands for quality of service, variants, any intellectual property boundaries, or maybe collaborations, patterns, or maybe any contracts missing of that. So an aspect is a representation of cross-cutting concern. So already we have seen cross-cutting concern is some characteristics of the system that applies across many different requirements. So it's a representation of cross-cutting concern. Cross-cutting concern in the sense the purpose of this aspect means it will deals the feature which gives an optimization, which is not should be repeated. Optimization way we can use all these concerns like maybe requirement concerns, use case concern, features concern, data structure concerns. All these are the concerns are there. Now, how optimizely you are going to presenting for cross-cutting concern. Best example, cross-cutting uh, cost. For example, cross-cutting cost in the sense what? If your monthly of your maybe spending of money is say for example 2000 as a student, that cross cutting for your cost means how you can cross cut means how you'll be best saved that 2000 instead of spending 2000 for a month. What you can do, make a cross cuttings over there. Out of that 2000 you can make a plan that what are the expenditures you are making for that 2000s, maybe for watching movies, recharges, or having snacks in the evenings or some other sort of things. All this of list of items where your expenditures, list of expenditures where you are spending your money. If you could cut some sort of items, if you remove over there, definitely you will be save your money. In the same fashion, the purpose of aspect is that see such a way that at which aspect this representation of the cross cutting can be optimized, can be optimizedly we can use it. Okay, so that's about the aspect. Now coming to the last concept, if design concepts is design classes. How better we can design the classes. Now what is a class? We'll study in UML. A class can be represented a set of attributes and operations. Or simply as part of the Java, what is a class? Simply we can making as a class can be defined for making a set of attributes will be there and set of operations will be there in a particular class. Now how to access that classes? We need to create some instances with the help of objects. Objects is an instance of class, means we are creating the soul of a class with the help of objects. In this concept, design classes, class represents a different layer of design architecture. Agree? Now this design architecture talks about 5 types of design classes, right? The first one, user interface class. Second, business domain class. Third one, process class. Fourth one, persistence class. Fifth one, system class. Let me talk about user interface class. In this name itself, user interface. Interface is act as a mediator, defines all abstractions that are necessary for human computer interaction. That is HCI, human computer interaction. It will be act as this class. Business domain class will deals with for refinement of the analysis classes that identify attributes and services to implement some business domain. So it deals with some attributes and some services over there which can provide to make a business. In the domains of business, we can make some refinement in the part of this attributes and services. So that type of interface comes under domain class. Now another is process class. So this class purpose is implements lower level business abstraction required to fulfill, that is fully manage the business domain classes. So process in the sense it will deals with the lower level details, lower level business abstraction, where how the business domain class will be make sure and the implementation of design domain class will be comes under process class. Coming to the persistence class, the purpose of this class is it will be go and store whatever the details is required. That is represent data stores that will persist beyond the execution of the software. And the last class is the system class, which deals with implements the management as well as the control functions. The purpose of this management, implementation, and control functions is to operate and communicate within the computer environment and with the outside world. The system class will deals to make a mediator between the client and server, how they are going to be managing inside the environment and outside the environment. Environment in the sense remotely and locally, how they are going to be accessing over there. So these are the 5 different design classes for representation of design architecture. One is user interface class, second business domain class, third process class, fourth persistent, and fifth one the system class. And as a summary of this total concept, here one best example for design classes. It is showing it is a class. How many classes are there in this figure? Floor plan is one class. Camera is another class. Window is another class. Wall segment is another class. These are type and outside dimensionalities is are called as attributes, class attributes. And the rest of this will be called as operations or methods. This also be a class. This is also be a class. This also be a class. Camera is a class. Window is a class. This wall segment is a class. Now for the segment class, start coordinate and end coordinate, both these two are called as attributes. And get type and draw is called as operations. So a class consisting of attributes and operations. For a 4-plan class, the attributes are type, outside dimensions. The operations are add camera, add wall, add window, delete segment, and so on. That is draw, right? So like this, we are going to be connecting to each other. In this example, it talks about like we'll talk later about this in detail about the class diagram, because we'll discuss in the UML diagrams what is this one indicates, star indicates. For one floor plan, we can have many number of cameras. If you consider our MNS block, we have different floors, minimum 4 to 5 floors are there. In each floors, we can have many number of cameras, one to many. So one floor plan, it deals with many. Star indicates many over here. The star indicates here many. And it is going to be aggregated. So these are the notations available in the class diagram. We'll talk later about that. Okay, so this is one example for discussion of this design classes, right? So what we have studied inside this design concept is we have studied about 11 different design concepts, such as abstraction, architecture, patterns, separation of concern, modularity, information hiding, functional independence, refinement, refactoring, aspects, design classes. So that's about this design concepts.